The objective of this lesson is to develop PRISM dimensions to solve real-world problems. In previous lessons, students have examined the attribute of volume and the relationship between volume and the dimensions of a given prism. In this lesson, we will incorporate this learning as we solve a real-world task. The first task reads, Adam sells cookie bars. Each bar is 2 inches square and 1 inch high. Adam sells them in boxes of 24. What size of boxes could be used to package the cookie bars? Students may use a variety of box dimensions while solving this problem, but it is important to note the volume of the package will remain the same regardless of the dimensions used. Each cookie bar is 2 inches by 2 inches by 1 inch, making the volume of each bar 4 cubic inches. Since Adam sells his bars in boxes of 24, we can calculate the total volume of the box by multiplying the number of bars in the box by the volume of each bar. 24 multiplied by 4 cubic inches is 96 cubic inches. The volume of the box will be 96 cubic inches. Now that we know the needed volume of the box, we can make sure any possible box dimensions we use have a total volume of 96 cubic inches. To help visualize this, we can use isometric paper. One possible box would be a single stack of 24 cookie bars. This box would stand 24 inches high since each cookie bar is 1 inch high. The other dimensions of the box would be identical to the dimensions of the cookie bars, 2 inches square. We can check for the needed volume by multiplying the box's dimensions. 2 inches multiplied by 2 inches multiplied by 24 inches. The volume of the box is 96 cubic inches. Of course, a box measuring 2 inches in length and width and 24 inches in height is not a very practical or reasonable box. We have provided an answer to the problem, but our solution does not necessarily fit the constraints of a real-world task. We can instead determine a new set of dimensions that will be more reasonable. For example, if we were to create a layer of 4 bars arranged in a square, we would only need 6 stacked layers to include all 24 cookie bars. The dimensions of a single layer of cookies would be 4 inches square and 1 inch high. 6 layers would make the box 6 inches high. To ensure we have the correct volume, we can multiply the volume of the base layer by the total number of layers. 4 inches multiplied by 4 inches multiplied by 1 inch is 16 cubic inches. The volume of the base layer is 16 cubic inches. We can now multiply the base by the height to calculate the full volume of the box. 16 cubic inches multiplied by 6, which is the number of layers, is 96 cubic inches. The volume of the box is 96 cubic inches. We have now determined a more reasonable box shape than our previous solution. Next, let's examine another scenario. When catering events, Adam transports his cookie bars in boxes of 60. What size boxes could be used for this? The process for solving this question is identical to the process we followed for the previous question. Because of this, some students may be tempted to use the same basic box shape they used in the previous question. For example, if they calculated the single stack box just as we did, they might simply calculate another single stack box for this second question. Though a 2-inch square box, 60 inches high, that's 5 feet, is even more unreasonable. Other possible and more reasonable box shapes can be discovered by looking at the different factors possible to make 60. For example, 10 layers of 6 cookies each, 5 layers of 12 cookies each, or 3 layers of 20 cookies each. Each of these possible shapes can be used to determine reasonable dimensions for a box Adam can use to transport 60 cookie bars. Each of these different box shapes have the exact same volume as the 5-foot-high single stack box of 60 cookie bars. The volume of all these box shapes is 240 cubic inches. The objective for this lesson was to develop PRISM dimensions to solve real-world problems. We met this objective by examining the volume needed to pack the given number of cookie bars, creating visuals of various box shapes, and checking the volume of our solution to ensure it matched the required volume.